All right, we are still on Unit 1, but we are going to move on to Topic 2, and we're going to try and answer the question, how do various map projections distort spatial relationships when compared to the globe? All right, so this question should be at the top of your notes page, because this is what we're going to try and answer after today. You should be able to answer this by the time we're done with the lesson. So, a quick review of topic 1. Maps are used to represent and identify physical, spatial, and temporal processes on Earth's surface. Cartography is the science of making maps, and where we spent most of our time on topic 1 was talking about those geospatial technologies, and how they allow geographers and cartographers to easily study the relationships between various physical and cultural processes. So we looked at those technologies and how they help us make maps and how they help us to study them. But what we are going to look at today is maps themselves, and actually how every single map you look at is wrong. In some way, every single map you look at is wrong. So all maps are inevitably distorted in shape, area, distance, and or direction. So they can be distorted in all of those things, or just one or the other. Distorted means messed up. So, how, like, whenever you're making a PowerPoint and you want to make a picture bigger, sometimes you stretch it and it distorts what the picture actually looks like. Well, that happens with maps. Every single map is distorted in some way. So maybe the shapes are different on the map than they are in real life. The area, so how big it is different. The distance between two places may be different, or the direction that you would need to go to get there may be different on the map than in real life. So the question I want you to think about, before we take notes, is, why do you think maps are inevitably distorted? And the key word here is inevitably. No matter what, every single map is going to be messed up in some way. So why do you think that is? Well, the answer is because maps are flat, but the earth is round. And so it's really hard to take something spherical and flatten it out. And I know you're thinking it can't be that hard, like, to flatten it out and make it look right. But I want you to look at this. This, I know it's weird, but this is someone's head unwrapped. Okay? And you can tell that the ears are way further away from the eyes than they're supposed to be, because it's unwrapped. This is not what his face looks like, and it's because they took a round object and they tried to flatten it out. And so this video does a really good job explaining that. So we're going to watch it real fast, and then talk about map distortions a little bit more.
All right, here we go. If I want to turn this globe into a flat map, I'm going to have to cut it open. In order to get this globe to look anything close to a rectangle lying flat, I've had to cut it in several places. I've had to stretch it so that the countries are starting to look all wonky. And even still, it's almost impossible to get it to lay flat. And that right there is the eternal dilemma of map makers. The surface of a sphere cannot be represented as a plane without some form of distortion. That was mathematically proved by this guy a long time ago. Since around the 1500s, mathematicians have set about creating algorithms that would translate the globe into something flat. And to do this, they use a process called projection. Popular rectangular maps use a cylindrical projection. Imagine putting a theoretical cylinder over the globe and projecting each of the points of the sphere onto the cylinder surface. Unroll the cylinder and you have a flat rectangular map. But you could also project the globe onto other objects. And the math used by map makers to project the globe will affect the way the map looks once it's all flattened out. And here's the big problem. Every one of these projections comes with trade-offs in shape, distance, direction, and land area. Certain map projections can either be misleading or very helpful depending on what you're using them for.
All right, so he showed you how difficult it would be to cut open a sphere and lay it flat. But that doesn't take away from the fact that we need maps. We need maps to study different aspects. We need maps to get places. And so, what cartographers do is they use different projections, and you saw how they made those, and they make different maps, and they're used depending on what you need to use them for. And so, what we're going to do to finish out topic 2 is talk about the different map projections, or a couple of the popular ones, and what they're used for and how they're actually distorted. And so these are called map projections. The first one we're going to look at is called the Mercator projection. The advantages, so the good things about this map is that the direction is not distorted. It's constant across the whole map. So if you left Miami, Florida, and you headed northeast, the direction is the same. Like, you would get where you needed to go. The shapes of the continents are correct, but the area is distorted near the poles. So the way this projection is done, it stretches out the north and the south poles really bad. So it makes them look a lot bigger than they are. So this projection is used mainly for navigation, getting places, because the direction is the same. And so if you're going somewhere, the direction is the most important part. So because the direction of the map isn't distorted, it's used for navigation. But I want to show you how distorted the area is. So the size of the poles are what's distorted in this map. If you look, this is Greenland. It looks bigger than Africa on this map, but this is the real size. So on the Mercator projection, this purple is what Greenland looks like. But in the real world, this is the actual size of Greenland compared to Africa. So you can see how this map projection would be good for traveling, but not so good in comparing anything that you would need to know the area of a certain place for. There's also the Peters projection. The area of the continents is accurate, but the shapes are very inaccurate. You can tell that, especially through the middle, it's stretched, and then the poles, the shapes of the continents are weird. Yeah, they don't look like they're supposed to, even though the area, so the size of them is accurate, but their shapes are weird. Yeah. This is the Peters projection. And then the Robinson projection, you've probably seen a lot in school, and that's because it's good. It's used for like general use because there are no major distortions, but all aspects are slightly distorted. So although it looks pretty close to an accurate map, the shape is distorted a little bit, the size is distorted a little bit, the area is distorted a little bit, and direction is distorted a little bit. So it's all distorted a little tiny bit, which makes it good for like general use, not really navigation, but in learning about the globe and the size of continents, or how to get somewhere in the direction. It's good. It's a good one map to use if you're going to talk about all of those things. So thinking about the process of flattening the globe and the different map projections. How do various map projections distort spatial relationships when compared to the globe? That's the question you need to answer in your summary of your notes. Let me know if you have any questions.